Thank you very much, Brian. Oh, I see. Just green button, go forward, red button to go back. Splendid. Hello. It's nice to meet you all. I'm very new to this scene. And the talk I've got to give today is one I've given versions of a few times. How's the? Yeah, okay. I've given versions of a few times. It's centered on the fellowship that I've got at the moment from the Software Sustainability Institute to look at applying the principles of research software, open science to research hardware. But I'm going to take you on some of the journey that I've been on, sort of getting to this point, what I'm finding out, what the plans for the fellowship are. And I hope that I'll be able to convey both enthusiasm and a bit of a cautionary tale to some of you here. So to tell you a little bit about me, this is some of my deep background. This picture comes from it's from the very first OpenStreetMap mapping party, 20 years ago. That's me in the green t-shirt on the left. So that at the time I was a software artist, and I'd become obsessed with geographic data because I wanted to make lots of locative media artwork and couldn't get hold of the data, and sort of passed through this scene, donated a lot of data, helped do some organizing and kick it off. And being involved in OSM, and also with the Open Source Geospatial Foundation, the Open Knowledge Foundation at the time, that changed the course of what I was doing. I went into more straight software development, did a lot of GIS work, and I've been working for about the last decade with different organizations that do land surveys of different kinds. So I was invited to come and give this talk here, and I'm still a bit mystified by why I was invited to give the talk. I'm starting to piece it together, and I'm hoping that I thought of doing a Mentimeter poll here at the beginning and the end, and to take the audience reaction of sort of why are you here, Joe? So potentially just for light relief, as a bit of a contrast with a vendor talk, to show some alternative futures that are maybe alternative presents, to draw on the cautionary tales of parts of my past work and how they apply now, and to bring this theme of resistance to scale. So as Brian mentioned, I'm currently a research software engineer at the UK Centre for Ecology and Hydrology. They're a lovely organization, very long established. This picture here shows one of their monitoring sites on Lake Windermere, with a continuous collection of data samples going back about 80 years. One of the lovely things about CH is they've got a kind of in-house hackerspace called the Engineering Workshop, and they collaborate with researchers, effectively they're research hardware engineers. This is a paper featuring one of their projects, which I love because it's not electronic. It's a series of ceramic plates that have been infused with different chemicals that grow algae differently, and they monitor the growth of algae in a river flume. And I spoke with one of the engineers who'd worked on this, who was very enthused about the challenges of being able to make a buoy that neither floats nor sinks, but stays midstream. And CEH also run educational workshops for field engineers, early career researchers. They do introductions to electronics. You get to sit down and do some programming of an ESP32. But in terms of their own projects, they're very large research infrastructure, high stakes, centrally funded work. They tend to go with in that field. It's Campbell Scientific, the kind of the vendors of high guarantee, extremely expensive devices, which then cause quite a lot of integration issues. There's interest in some of these projects and their research partners in working with developing open networks, open source hardware. But when it matters in terms of needing to guarantee you can show deliverables to funders, the installations end up looking something like this. This is part of a trial site for the new floods and droughts research infrastructure. Um, and there's a whole world out there of these micro devices that are open source, open licensed, reproducible. And I've got a wee selection to show you some of the picture before I go into the story of how I started coming across all of this stuff. This is a Bluetooth soil moisture sensor. It comes from an organization called, well, they don't manufacture this, they resell it from Labcrafter. I definitely recommend looking up Labcrafter. And they sell a whole range of open hardware, scientific devices. I'm not sure they still have this in stock. You know, this is the kind of product that comes from an enthusiast hobbyist market, but into research, real research purposes. This is a lovely project from an organization in the US, which has been in this line of work for a decade plus, the Stroud Water Research Center. It's the Hydromoth, so it's their own custom work, custom PCB. It's an underwater version of, no, hang on. Is this, sorry, I'm getting my projects mixed up. So this is, the Hydromoth is part of the Audiomoth line of work. The Stroud Water Research Center have a very similar device called the Mayfly. And this is an underwater acoustic sensor. Again, it's all, the PCBs are reproducible. You can fabricate your own, you can order them from the US, and the shipping costs are now probably more than the device is worth. This is a lovely project from Digital Naturalism. They're based in Panama. And this is another open hardware project. It's a moth sensor, where it's shining UV light on a panel, capturing images of the moths that are attracted to it at night. There's a bit of machine learning in there, so you're doing tracking of individuals, you're doing classification of individual species, and they've got massive installations of dozens of these things out in the field. And you know, it's a moral equivalent to this project, which was an early CEH attempt to do the same thing called the AMI, the Automated Monitoring of Insects sensor setup. This is my now ex-colleague Albert setting up one of the AMI devices. This wasn't open hardware. I'd love to be able to change that. And I think there was an opportunity missed in terms of collaboration across research groups by not taking this path. So how did I get interested in all of this? So the Software Sustainability Institute had its call for fellowships, and I'm assuming that most people here do know of the SSI and what they support. So they were and are a really pioneering organization, not just in the UK, but I think globally in terms of taking the profession of research software engineer and formalizing it, organizing a supportive community around it. They have a fellowship scheme every year. I think at least one Robert there, at least one other member of my fellowship cohort is in this, is on the speaker list for this conference. So I thought, you know, what would I do if someone offered, you know, it's £4,000 in total per year to organize workshops, to do community outreach. And I pitched them a theme of applying the principles of open source software to research hardware. And I had zero context for this. This was a sort of, it came from sitting in project meetings at CEH thinking, you know, why are you looking at cutting back 10% of your sensor network because you can't afford the ongoing licensing fees on the data logger hardware? So I came up with a proposal to try and organize a series of workshops that brought together researchers from different communities, from my workplace, with people, especially with kind of hobbyist electronic tinkerers involved in the network of UK hacker spaces, maker spaces that I've been drifting around in for some time. This is an absolutely typical scene from my local, the Edinburgh Hack Lab, complete with, it's worth turning your head to catch the large view, these lovely array of 3D printed protective cat ears that you have to wear while soldering. And then once I put in this proposal, I was so happy to have it accepted. and then started to very hurriedly build up a picture of the groundwork. And now some of the kind of the pioneering researchers at CEH sent me a lot of reference points. The Gathering for Open Science Hardware is one. Although their motto, which is something like, making open source hardware that the scientific default by 2025, I think that probably needs a bit of revision, but they're a very engaged community that go um, way beyond environmental research. There's a lot of people working on lab devices, different kinds of imaging, DNA sampling, and so on. It's a really, really interesting community of people. And the wonderful OSHWA, the Open Source Hardware Association. And if you have not come across the work of OSHWA, I can highly recommend looking them up, and I'll go into a bit more detail about how they operate and what they do. They ran an open hardware summit earlier this year, and it came to Edinburgh, my hometown, and I was thrilled. It was like a traveling circus. It passed through Edinburgh, wanting to carry you away with their incredible array of micro devices and enthusiastic, supportive community. Um, Also, the Wuthering Bites Festival, I went to that last year just on my own bat to meet with some people and kind of scope out what the community looks like in the UK. They have an open source hardware camp, and again, that's been going for many, many years, but a kind of enthusiast, hobbyist, very retro computing oriented atmosphere, which probably has a new relevance now. Um, I'm veering. Please hold up any signs, Brian, that say "Stay on track, Joe." So OSHWA, the main reason for them to exist as a society community is to provide certification. So this is like a template for the certification they offer. You can think of this as like in the early days of open data, I think there still is an open definition which drew on the free software definitions, different sets of principles that just set out very clearly, here are the criteria by which you can say that your work is open, and here's the consensus agreement. And I think that open definition, it's cited in things like the Open Government License for data. So OSHWA's open hardware certification process is the same thing, not specifically for research hardware, for any kind of device. Doesn't have to be electronic. Some of them are just, like a tiny little clamp. It's OSHWA certified, just to be able to test the process. And I'd assumed when I'd encountered them that this was a subscription model, that this was how they kept the organization going. You pay for certification, but no, they do it for free. And they're lovely people. They did a 12-hour fundraising live stream, I think just last week. And it's definitely worth looking that up on their YouTube channel to see the huge range of projects, and especially to get some insight into what people doing lab focused work are doing now around open source hardware. I also came across the amazing line of work of Julian, whose surname I've forgotten, Julian Sterling. And this absolutely key paper from several years ago now, open instrumentation, like open data, is the key to reproducible science. Yet without incentives, it won't thrive. And it's got a very well-developed manifesto, view of the prior art. There is far more to open science than simply not shutting away your work. And I can firmly urge everyone here to go and take in this paper. Unlike me, Julian has got prototypes. And OpenFlexure is the main physical manifestation of that line of work. It's a like high power, high fidelity microscope suitable for lab work, and it's all open hardware. You can buy it in kit form and 3D print most of the components, or you can buy it off the shelf from someone like LabCrafter. And so this was a really, really pioneering project in this area of open source instrumentation. Deep breath. I'm going to pause for a second and have a quick drink of water, but you can admire this beautiful This beautiful futuristic object. This is a concept design. It's not really a working device. And it was done by Libby Miller, who was at BBC R&D for a long time, doing kind of playful work with physical prototypes and workshops, including the kind of people you wouldn't normally find in that sort of setting. So in this example, this is the BBC R&D did like 100 objects, and this is the 100th object. And it was designed mostly by school children as this sort of futuristic mushroom sensor that's, I'm not really sure how it works. It's reaching into the ground and sending back sound waves, and it's gauging the mushroom activity in some way. So I've enlisted Libby from the outset in my proposal and plans for the SSI Fellowship this year. And it's thanks to Libby's enthusiasm that I'm actually able to start getting workshops off the ground. There's one running this weekend, which is in a kind of slightly deprived area of Bristol called Knowles West, but with a quite interesting ecosystem. And so that's bringing in, families with young kids, as well as ecologists, folks from Bristol Wireless, from the local hackerspace. They probably still got space. If anyone's really interested in going, please talk to me. And this is one of Libby's more recent prototypes. Um, this is part of a sort of challenge yourself to make something every day in May activity called Make with a Y. So it's a bat sensor. Yes, it's a bat sensor with option of it being a bird sensor made out of cardboard. It's got Raspberry Pi inside, and it's running a fairly lightweight deep learning model from one of a series from AccuPy. So they do birds identification, bat identification. The classification part leaves me a bit cold, but it's got LoRaWAN in it, and is sending back, oh, I've seen this bird, I've intercepted this bat, I've heard its calls, this is where it's heading. And so that's kind of the theme of the workshop in this series that Libby's helping to run, and drawing on that experience of having done these things with BBC R&D to help come up with a template for engagement. Um, I think that, excuse me, that there are often researchers working in this field, whether that is the technologists or the environmentalists, or an awkward combination of both, can rush into new projects with enthusiasm without necessarily thinking through the consequences, the alternative applications, the underlying why they're building what they're building. So, I mean, this is an example from one of my UKCH colleagues, Jenna Lawson, um, and the blurry blob in the top right is a drone, and what it's doing is it's firing projectiles that have got a micro moth, which is the sort of thumbnail size version of that bioacoustic sensor, into different levels of the tree, so that you can monitor the bird soundscape and follow activity at different levels of the tree canopy. And that's absolutely lovely if you want to be able to understand why you're seeing a lot more activity in this part of the tree canopy, why you can't do this with ground-based sensors, but you do want to start intercepting that drive to, not thinking about why we did it because we could and didn't necessarily think through why we should. Oh, yeah, the best. Yeah, why not? The best story that I've had from a colleague, again, was about a recreational project. This is Linda May, who's an extremely respected freshwater ecologist, but also a tinkerer. And she'd done a DIY gardening project it was an electric fence for slugs. And she discovered that the capacitive properties of the slugs were such that you could run like two different metallic strips along the garden and put a very low power shock through them to stop them going where slugs shouldn't go. And this worked fine for a while, she told me, and then eventually the slugs got used to the sensation of being electrified, and so she upped the voltage. and went through a few iterations of, it worked again for a while. And then eventually, yeah, went down to the garden one morning to find a strip of fried slugs. And I think of Linda's story often, and of the, and I, in that setting, I draw on some of my past experiences of the unforeseen consequences that the people running around doing locative media art, coming up with all of these fanciful concept designs about how wouldn't it be wonderful if we had a tiny computer in our pocket and it knew where we were and we could use it to reach out to a whole network of our friends, and the purposes to which the aspirations have been put. So, it's sort of both, it's partly held me back from doing more outreach, more development, but at the same time, I understand that we can't not in some really fundamental way. And the important part is to come up with a kind of a framing for what we're developing and how that builds in, to the extent possible, that resistance to misuse. So it is not just about conceptually paralyzing yourself by thinking through all of the potential negative applications, but trying to build guardrails isn't really the word, is it? I'm not really sure what the word is. So this lovely slide, it comes from a talk by Dan McQuillan, who an academic in London who quite a few years ago now wrote a book called Resisting AI, which I've still never read. And more recently, Dan's key phrase has been this of decomputing of, what is the holistic approach to the future for resisting the inclination, the tendencies, the framework in which we are building tools that are necessarily not being put into hands and with purposes that we would condone did we know. Are we, in terms of the analogs for environmental data, environmental monitoring, a lot of the interest in the new gen of micro devices is being driven by the ease of AI applications, by the kinds of analyses that can now be done at scale with acoustic data, with imaging data, with LiDAR. There's a whole line of environmental DNA where you've got a small sampling device and the ability to do the kind of show me the DNA scape of this room at this moment is becoming nearer and nearer to real time. So there's a lot that it feels important to think through in assessing like this. And I'm starting to run out of talk, which is perfect because I've got 5 minutes left. How wonderful timing. So I have a lot of terrible ideas. A lot of my current terrible ideas are dog tech. Um, this is a concept design for, again, it's a sort of dog backpack data collector. And you feel, yeah, the dog is wandering around the forest anyway. It's doing its own kind of information sharing against this tree. Why not build in your cluster into the tree roots and do I necessarily want to start developing a line of work that turns its subjects into beasts of burden for a data collection initiative? And can I fully think through how that is going to be turned back upon me? Right, okay, I'm going to stop extemporizing. And so this is the current prototype site, to avoid having any more unfortunate thoughts about dog tech. This is the tiny pond, our offices in Edinburgh. And we've had one meeting so far about, what can we do to make a digital twin of this tiny pond? And really, it's an exercise in applied sarcasm as much as anything else. But there have been some lovely brainstorming discussions in a certain time of year where you see all aquatic life, newts and tadpoles and weird scorpion prawn things eating the tadpoles. And so I think that's something that I've learned from differently shaped attempts to work with different people to get workshops off the ground, is to root them at a physical site and in its physical needs. and also have a way to have that kind of conversation in a really casual, standing around together. And this is it's an arbitrary plug. I love this project. So the RC 2014 it's a hobby retro computer. This is its mini Picasso version. I still haven't finished soldering mine, and I love it for several reasons. So, it's a modern retro computer. It's got the space there for it. It's 8-bit Z80 chip. It's got this wonderfully sort of intentionally wonky, wobbly design. And it came about as an April Fool's joke. So, there's a sort of blog post talking about how happy the electrons are to be wriggling around the circuit, but no, it's actually also a shippable product. And there is there's a whole set of much more usable and predictable releases of the RC 2014. And there's a joyful community around it. And as a hardware prototype, it now also it pretty much supports the person who put it together. That's the end of my talk. Great. Please, I'm very new to all of this. There's only about 2 people I know in this whole room, so please do come and talk to me about things you care about. You.
Thank you, Joe. So I actually like the dog tech, just because, for the purpose of what it might be. But I think some of the greatest videos I've ever seen is when someone's put on a little camera on their cat or dog. You have the day in the life of the cat and the dog, because we're always interested to see what they're up to. You only see them from whenever they want things from you sometimes. But I always found that entertaining. So it's always about the purpose. Any questions from the audience for Joe?
Stunned silence.
We got one for Carol.
Thank you. Hello, I'm from the Software Sustainability Institute, so it's really interesting to hear about what you've been doing. So how do you feel that those workshops have been going so far do you feel you're making the progress you want to?
Not yet. Not yet. And that is partly, sadly, it's a question of time for me. So it's all a personal project. It's come about because of the context of my employers, but I don't get day job time, and I want to sort of guard my non-working time so carefully, and it's hard to operate in that gray area. So I'm doing a lot better, and I think I went into it with a very, very open-ended, bring a lot of people, components, settings into a room, rather than trying to focus it around, here's someone with a passion project and a set of needs, and that might end up shaped differently according to who else comes and interacts with that. So that example of Libby and the cardboard box back detector is one, and there's another person who is like combination instrument engineer and Hack Lab member who's got a lovely bird box design, and that's very sympathetic, and you get audio from inside the bird box, and you're monitoring the bird health with an air quality sensor. So that, yeah, it's trying to theme it around, okay, here's someone with a strong idea already that needs refined, rather than this extremely open-ended, what can we do in this empty room version that that might work for me, but not for other people. But yeah, it's not where I'd love it to be, but it's been a lovely bootstrapping opportunity, Mm.
Okay, Mark.
Thanks, Joe. Very thought-provoking talk. And so I was just wondering about lessons or things that we could draw for kind of let's say the HPC or AI community. I mean, one obvious one is the focusing on what it is, what outcome you're looking for, and trying to design the hardware solution around that. But I was wondering other things you could already draw out of it for other communities.
Interesting. I think I'm going to have a much better shot at answering that question at the end of the 2-day conference than at the start. But Yeah, I hear that theme in the opening keynote talk about appropriate hardware for the job. Martin, a Mastodon Fediverse friend who is here somewhere, was saying, yeah, there you are. Don't stop shrinking away. 4-bit is the new hotness, and there's a clearer need to revisit some of the retro computing in the light of, I forget the term for the model pruning. Yeah, but no, I don't have. I'll place that question in the back of my mind and look for answers for it over the 2 days. Thank you.